This conference is brought to you by CallStack, your React and React Native development experts.
My name's Matt. I teach TypeScript and AI for a living. And if you haven't heard about it, AI is here. AI is that weird colleague that's kind of hanging around the water cooler. You don't know whether they're here to take your job or to do your job better than you or do your job worse than you but take the credit. And it's incumbent on all of us, I think, as developers to make the most of it and to understand how it works. And that, I think, is a fallacy that a lot of people get into when they start working with AI. They want to learn it from the inside out. They want to understand its internals, to see the source code, right? But you can't really do that with AI. AI is a black box. It is just a huge set of weights that the model providers don't even know what they've created. There are entire divisions at OpenAI and Anthropic to interpretability, trying to work out exactly what all the numbers mean. So unless you go and get a PhD in machine learning or something, understanding how it works on the inside is not going to tell you how to use it from the outside. So I don't think you should learn it from the inside out. I think you should learn it from the outside in. Instead of thinking, how does it work, we should think, how does it behave? Let's use it. Let's leverage it. Let's work with it. And the way that you do that is you work with it a lot. Not only do you work with it, but you build with it. And I personally think that the best way certainly I've found, of getting to know AI better and understanding and starting to feel a bit of empathy with the machine is to build AI-powered apps. Build apps that contain AI, that leverage AI, and use workflows to automate some of the stuff that I do from day to day. And you might be thinking, I don't want to do that. I don't want to learn Python. I don't want to get out of my comfortable ecosystem. I don't want to learn a bunch of new tools. That sounds impossible. How the hell do I do that? Well, the AI SDK is the thing that you need to be learning. And just by running npm add AI, you start entering into a whole world of interesting stuff. Now, the AI SDK comes in two main bits. You've got the core, which runs on Node and Bun and Dino, and actually anywhere JavaScript runs. And it's built by Vercel, but it runs anywhere. It doesn't just run on Vercel. And you've got the UI part. So the UI part links up to the core. So if you've got the core, which is your backend, you've got the UI, which is your front end. Some apps just need the backend stuff. Many apps will need the connection between both. And it can work with React, Svelte, Vue, Angular, whatever. So what are the problems that we need to handle when we're dealing with working with LLMs programmatically? Well, we need to contact the LLM, right? We need to chat to it. We need to get responses back from it. We need to send stuff to it, receive things back. And surely what you could do with that is just use the OpenAI SDK, right? All of these model providers, they have SDKs that you can hook into and just go, yeah, I'll use that. I need OpenAI. Let's use the SDK. What about streaming to and from the front end? That's a bit more complicated because there's stuff that comes through those streams that isn't text. You know, in 2022, you used to have like LLMs could only do text. Now they do images, reasoning tokens, tool calls, structured outputs. That's a bit more complicated, right? Well, surely you could just use the OpenAI SDK instead, right? Need OpenAI? Let's use OpenAI stuff. Well, you get a few months down the line and you realize, okay, there's actually a really nice Anthropic model that's come out, really nice Google model. Maybe we should try a local model. And you realize, oh no, I've vendor locked myself into a single third-party provider that I don't control. Every part of my code now depends on the weird behaviors in OpenAI's API. I have no control over where my code goes from here. I've got to wrap everything in if statements. So if we call Anthropic, we do this. If we call OpenAI, we do this. So vendor lock-in is a massive problem, except it's sort of a solved problem with the AI SDK. Wouldn't it be great if there was a single unified API that you could just change with a single line of code to use OpenAI, Anthropic, Google, XAI, Mistral, many, 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 many more. And also from a learning perspective, from a trying it out perspective, It means there's just one thing to learn, right? Which is really attractive when you're just getting into the space for the first time. You don't need to learn the weirdnesses with every single LLM provider and what they do differently. It's one thing to learn. So let's learn it. I'm going to be, for those on their laptops who prefer to look at code than look at me, I'm going to be on Matt Pocock Poland AI Talk repo, and let's actually explain this. And yeah, I'm going to be using conference Wi-Fi to talk to an LLM, so let's see how that goes. We have here a generateText call, right? At the top, you can see we're importing generateText from AI, and we're passing it two things. We are passing it a model, which we're importing from Google AI SDK Google. I have in my environment variables a Google generative API key that I got from there. There's a free tier, by the way, which is nice. And I'm passing it that model and a prompt. That's it. And when I run this too, oops, let's run, for those following along, pm dev. And what we get out of this is we wait for a bit, and then we see a paragraph being pulled in, okay? Notice how that happened, right? We waited, and then we got something back. generateText, that's it. What about generating more complicated things? Because text is fun. Text is fun for generating content or summaries of things, but it's less fun for turning unstructured data into structured data, which is a really great thing you can do with LLMs, for tagging data, for organizing things. Well, we've got a generateObject call down the bottom. Let me uncomment this. generateObject takes in the model, takes in a prompt, and this time it's give me an array of key facts from the following text. So we're generating some text and then pulling out key facts from it. And we pass in the result.text, remove all flowery language, speak as if you are a scientist. And we pass in a Zod schema. And this Zod schema is doing maybe double or triple duty for us because it's first of all describes to the LLM what shape of object we want back, right? So you've got an object here of facts, which is an array of strings, and we can describe that too. We can actually say to the LLM, this is an array of key facts from the text, okay? Not only does it do that, but when the LLM generates this, the LLM is going to return some JSON for us. It's going to pass that out into an actual JavaScript object, and it's going to validate it using Zod. So if it fails, Zod's going to actually error for us, which means we can guarantee at runtime that this object.result.object is in fact an object with an array of facts string. Let's run this, see how it works. And what we should get is we generate the text, and then we generate the object immediately afterwards. And Xylos is a planet with perpetual twilight. Beautiful. So, generating is pretty good. But what about most UIs that you see will involve streaming, right? There is a really key metric in AI-powered app world, which is called TTFT, time to first token. In our previous setup, our TTFT was really bad because we waited for the entire thing to be generated and only then showed it to the user. What if we could stream it in as the LLM generates it? Well, we can with streamText. That's all we did. We locked away generateText and we brought in streamText. And this time, instead of just console logging the results, we are streaming it to the console via process.standardout.write. Let's run this. Bum, 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 bum. And you notice it streams in token by token. Okay? This is much more like what you're going to be doing if you're doing anything with a UI. For just pipelines, things that happen in the background, you can use generateText, generateObject. For stuff that needs a UI, you really need streamText, and of course, there's streamObject too. Now, streamObject, I think it might be one of my favorite APIs, actually. We're just doing exactly the same thing as before. We've got result.text, remove all flowery language, blah, 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 same schema. But this time, instead of just console logging the results, we are logging out a chunk of a partial object stream. So this one is going to create the object piece by piece, streaming in the facts. Let's run it. It is very, very nice to watch. So streamText, stream, time to first token, doing pretty well. And then the facts stream in too. So we can look at this in the logs. We first start out with an empty object. Then we get one with just one fact. then another fact, and this one fully loaded in, all the facts currently streaming in, and you can imagine the kind of UIs that you can build with this, right? Really responsive stuff, streaming in stuff as it's being generated in a format that's validated by Zod. It's beautiful. So that's cool. I was talking before about how we can actually choose different models and just swap them over really quickly. So let's do that. We've got our Google model here, Gemini 2.0 Flash. How do I swap it to an Anthropic model? Well, I do this, Anthropic. And then inside this string, I just choose the model I want. There it is. No more stress, no more lock-in. It's just right there. Let's go for Haiku. I love that Haiku. Let's run this. 1.2, problem. And Anthropic streams in instead of Google. Of course, I've got an Anthropic API key in my environment variables too. So again, we're just protecting ourselves, giving ourselves a layer of wonderful protection against the horrible curse of vendor lock-in. And of course, you can build cool things like this, like model selectors, and trying different models for different reasons, or trying one model against another and comparing the outputs. Really nice stuff. So how does this look when you're talking about a UI, right? Let's actually run this first. So I'm going to run pnpm dev. Now, I'm going to run this on localhost 3000. Let's open this up. You'll probably see all my bookmarks, won't you? Yeah, let's not show that too closely. There we go. And let's ask it, what is the capital of France? And before I do this, I'm going to open up the network tab so you can see what's going on. What's the capital of France? We open this up, and it pings localhost 3000 /chat, API /chat. So that's what it's doing. Okay? And what it's sending is it's sending an array of messages, and this array of messages just happens to contain the one message that we created first. What is the capital of France? Okay? And we end up with something being streamed back. Now the code for this is so nice. Show me the code. There's the code. Let's take a look inside client root.tsx, and the code for this is this useChat call, which, as we can see from the top, is coming from useChat AI SDK React. Okay? useChat, by default, all it's doing is just creating or maintaining for you a list of messages in state, and then we can go down to this wrapper down here and just render the messages. That's all we're doing. We've got a chat inputs here where we send the message, and that's really all the state you need. By default, then, it contacts API chat. So let's have a look at API chat. Inside here, this is like a typical post request like you might see in an XJS application. We are taking the messages from the body, and they are of the type UI message from AI, okay? A really important type in AI SDK world. We are then converting them from a front-end representation from the UI message into a model message. Okay? UI messages and model messages. Model messages much simpler. You don't really need to send the model that much information. And then we stream the text from the model. Instead of passing in prompt, we're now passing in a history of messages here. We turn that into a stream, and then we turn that stream into a response. And we bung it back down to the client. So let's take a look inside the event stream for what happened. We can see it started. How's the size, by the way? Need to be a bit bigger? I think we're good. We've got, it starts, then text starts streaming, then a text delta comes in, another text delta comes in, another text delta comes in, and a text end. And the AI SDK takes that stream of chunks and turns them onto messages that we can render in the front end. Beautiful. Now that's cool. Contacting an LLM via a UI, that's nice. But what about doing things with the LLM in the world, right? You've probably heard of, if you've been around this stuff, MCP or tools or things like that. And tools with the AI SDK are just an absolute dream. So we're going to go for type-safe tools. Let's run this. And the thing with tools is it really doesn't take much to build an agent in the AI SDK. You've probably heard of AI agents, right? And AI agents get a lot of hype, but they're actually extremely simple to build. All you need is to be able to get the LLM to take multiple steps, and at each step, receives some feedback from the world that it's in. Okay? So by some definitions, a thermostat is an agent. So here we've got a bunch of tools here, and they're tools defined using tool from the AI SDK, and each tool is about a file system operation. So we've got a tool here saying write to a file. We define an input schema using Zod again, and that input schema declares to the LLM what it can call this function with. So here we're saying, sure, you can pass a path, and we document it for it. You can pass some content too. And by the way, this is sandbox, so it's not going to destroy my entire laptop, which would be not very fun. And then we pass an execute function to it. And the execute function is, it's not going to be obviously sent to the LLM and like executed on its remote servers. What's going to happen is, we're going to send this information to the LLM, it's going to decide what to do, and then we're going to execute it based on its commands, and then feed that back to the LLM. That is what tool calling is. And by doing this, by having write file, read file, blah, 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 we go all the way down to a streamText call here, and we're passing in the model messages, same as we did before, and we have a system prompt that just says a few things. You're a helpful assistant, you've got a sandbox file system. Use markdown files to store information. We've also got this crucial line of code, which I'll talk about in a second. But let's test this out. We should have, tell me what to-do items I have today. It's read the file, path.todo, and it's you have the following to-do items today. Write my talk. We can check this out, and we can see that in the event stream, it called a tool. It said tool input start, tool output available, and it finished a step and started a new step just here. Then it pulled out the information. So it went out into my file system. It found some information for me and then summarized the information for me. And just so I'm proving that I'm not a charlatan, it is up here inside data file system todo.md. Very nice. So of course, this is a very simple version of tools, but there are infinite possibilities for tools, right? And connecting them to existing knowledge sources, doing all sorts of fun stuff. But let's focus on how easy the AI SDK makes it to render it on the front end. The version 5 of the AI SDK is just so nice because it makes this end-to-end type safe. So what we get is inside API chat here, we looked at these tools. We can, using a nice bit of TypeScript magic, declare a UI message type at the top here that's different from the default one. This is my UI message. And this my UI message knows about the shape of my tools here. So it knows about write file and read file and delete path, etc. And so now, if I go to where it's being used, if I do a go to definition on my UI message, I can see it's being used in components, the message components. And this message takes in an array of my UI message parts. That's all it takes to render a message, by the way, just the role, as in who created it, was it the user or the assistant? And then the parts of the message. And then to render it, all I do is I just map over each of the parts. These hovers are absolutely getting me today. So here, if it's a text part, then we render it with React Markdown. And I can see here that if I hover over this, I get autocomplete. Not only on the built-in stuff, like sources and documents and reasoning and that kind of thing, but also on my tool calls, on the exact names of my tool calls, tool list directory, tool read file, tool write file, etc. It's all in there. And if I get this wrong, or if I go into my API chat and rename it to write file, for instance, like this, uppercase, then it's going to error at me until I get it right. And of course, I get autocomplete to do it. So, so nice. This is new in version 5, which dropped relatively recently. So we can see how simple this all makes this. We get really the power of an agent with very little lines, very few lines of code. Now, I said that I would talk about this last little line here. Stop when step count is 10. We saw in the network tab that it took multiple steps, right? That's what makes an agent, is it's able to take one step, where it calls the tool, and take another step where it reacts to that tool call. If I were to remove this, let's say, and go back, and we'll run it one more time, tell me what to-do items I have for today, it's going to be next to useless. So it's called a tool here. But because I told it you have to finish at step 1, or that's the default, it finishes at step 1, it's not going to react to that tool call. Whereas, if I say stop when the step count is 10, I'm basically saying to the LLM, I'm going to stop you at step 10. But before that, you can decide when to stop. And that's what an agent is, really. You're handing over the control flow of your program to an LLM. You're saying to the LLM, you decide when to stop. It's fine. If you really want to go nuts, you can even do like step counters infinity, if you've just got, money to burn. But that's it. And just like that, we have declared a loop which the agent is able to just sort of run through and react to the things that it finds in the world, which is really cool. Now, you might be looking at this and thinking, that's great. The AI SDK is a gateway. I can use this as a way to get into AI, and I can, into the world of AI, but once I'm there, surely I'll find more mature tools that I can dig into. I'll pick out a framework, I'll use LangGraph or LangChain or something. But no, I don't think of it as a gateway that just sort of gets you into it. I think of it as a highway. Once you get on the AI SDK highway, it has primitives that can take you all the way to production applications. And it's used by a ton of different folks who are all building high-capacity, really complex stuff. And just these 4 simple primitives, really, generateText, streamText, generateObject, streamObject, and a few others that I haven't had time to talk about. Honestly, I think it's just one of the best designed TypeScript libraries that I've ever used, and it happens to come at a moment when everyone needs to get into AI. I think of it as the perfect abstraction. And I would encourage all of you to go out, try it out, build things with AI, and learn, not necessarily to love the machine, but also just to understand it. Because I think our careers in the next few years are going to depend on it. So thank you very much.